Okay, this purchase orders open log is the trial set, the test
it
set
is the
rather.
test set of open cases.
Okay,
Yeah.
that's got about 5,000 events in it. So I've got it loaded up. It had to be converted to XES format because that already takes XES. So hit predictably modern log, create a new data flow, call it demo, and I'll select all of the different predictions we have. So the 4 predictions we have is delay rank, which divides the chance of it being late into 4 different buckets, everything from will be just in time to severely late. Late supply, which does sort of a similar thing. It's a percentage chance of the.
It's the likelihood that is the likelihood of how much our case will exceed the target supply date. Yeah, we have a target supply date for each case.
Yeah.
And the probability that we will exceed that date.
Okay, so there's a percentage chance of blowing the deadline.
Yeah.
Next activity, which predicts the which activity would be next in the flowchart. And predicted completion, which is the date on which it's expected to complete. So they all kind of relate to one another, and we should be able to see whether they. So select our demo and hit 2 buttons, one to load the data in and one to start looking at the simulation.
Here it goes.
Yeah. So what have we got? At the beginning, there's something weird about this log. At the beginning, a whole bunch of stuff like blows its deadlines. We got a bunch of just terrible ones at the start. Color-coded, I've done a little bit of color coding here where the color of any given row is that slight varying light gray color is just hashed based on the case ID. So that's so that if as the events scroll down, you can kind of see them scrolling. Otherwise, it just changes, and you don't really get the sense of motion. The thing is coming down as this new events coming to the top. The color coding on the late supply column is green means things are going to go well, and red means we're going to be late. So I've actually seen examples of everything from almost 0% to 100% there. And the delay rank are various. Everything from white for just in time down to red for definitely severely going to blow your date. And I think that's all the color coding in there. Normally, we would have this completed cases, events per completed case, and average case duration. This test set doesn't explicitly was all the events that didn't complete. So this thing will stay at 0 and we'll never get a completed process for which you could calculate a duration. So that's why a bunch of these aggregate statistics at the top make no sense. So they're not doing anything interesting here. The system also could work quite a bit faster. I've set it up so that the events are throttled to come in 2 per second pretty much. And that's why it's running at a pretty, sedate pace. We can actually see it scrolling around. If you run as fast as my laptop can work, you get 20 to 25 events, and they're like entire screens worth, so the screen's just scrolling really quickly. The notion with this thing is it was designed so that it would handle live data, so it'll process data as quickly as you give it, if you give it quickly. So we've artificially slowed it down so the events are coming 2 a second. All right, anything else you need to say?
Yeah, also I would like to add that the predictive models that we are using here, they have been trained using the training component of Nirdizati tool, the one for which we have a separate video. And shortly we plan to integrate this training component with the runtime component so that they make up one tool.
Yeah, that's true. At the moment, what I've done is Ilya's handed me the training data, and I've just hard coded it into the system. But we have the really nice user interface that Stanislav developed that needs to be plugged in to replace my original version. So yeah. The notion is that you load up a log, you do the training, you construct those predictors locally, and then you just go. So we've almost got this to the point where it's like a usable tool.
Yeah, so the model that the training to outputs, it's automatically captured by the dashboard. Even if you retrain the model, I think it could catch it on the fly and update the
Yeah,
results.
yeah, it could. It could. You can, because each of these things is using a data flow architecture, you can rip out a component and replace it, and it just picks up the data where it left.
Yeah, because occasionally we would need to retrain the model, apparently, based on newer data.
Yeah.
So yeah, that
Well,
that
in
would come handy.
principle, this could be adjusting your training weights as it comes in. It's just at the moment that it's fixed at the beginning.
Yeah, I think that's it
Okay.
for now.
Enough then. All right, I'll shut it down. And we should be done. Okay. Oh, heck.